In this session, we will be solving basic Python programs. Programs where you have input, then you do some processing and output. Output might be formatted in different ways depending on the data type of the variable. Before we go into solving problems and writing programs, let us take a quick overview of different ways of formatting output in Python. What you see here is py, and in lines 2, 3, 4, 5, 6, and 7, maybe later, you will see multiple ways or different ways of formatting the output. First, if you don't want to do any formatting for py, just print py. So the first output of my code will be the print without any formatting, like this one. No format. Whatever you have will be output. Next, what you see in lines 3, 4, and 6, and 5 and 7 are different ways of formatting the output. They all do the same. Some of them are recent styles in latest Python editions. So let's see the first one. For example, if you want to format py to only show three decimals instead of 10 or 15 like this here. I can add some more figures here. So you can just do py, then percent. Percent.2f. F means float. Dot 3 means I want only 3 decimals. Percent py. This is one syntax. This is one syntax. Let me here put 1. So you see the first style. When I run this, see number 1 in the output. Here, number 1, Python 3.235. You see 3 decimals. If you want more decimal, just put 5 if you need 5. Run. Again, we see here 5 decimals. This is one way of formatting output in Python. The other way is a bit easier by using the format word and using what we call a placeholder. For example, here you would do py is equal to. Then you use curly braces. Curly braces are useful when you have multiple things to output. Then you do the same thing, but the syntax is different here. Use :.2f or 3f. It's up to you and depending on the example. So here I did everything and then I used format py. Now where py is going to be added in the output, exactly where you see the curly braces. This is called a placeholder. So py, the value of py will be placed here. If you do not put any formatting, it will be output without any formatting. If you want some formatting here, do not use percent, use : dot, for example, 2f. So now, in the second output, what you're going to see is the same format here, 2, 3.23, as you see here. You want 5, that's fine. Go ahead and do 5. Here's line 2, and this is the output. In the third one, we see the latest style of Python and the simplest, what they call f string. This f does a lot of things. Here, instead of using format py, you just put f here. Then exactly the same syntax. You put py here, and then you can say py 3f. If you don't put anything, any format, your output will be like this. F and the value of py without any format. Let me put 3 here, and you see the output at line 3. Clear some space. Run. So you see at line 3, you get the value of py without any format. but it will be placed here inside the placeholder. The syntax is easier. Now, if you want to do some formatting, that's fine. You just can go ahead and do colon, whatever format needed. Let me just add 3 so our output is clear now. So with f string, you can either place the variable wherever you want inside the curly braces, or you can do both, placing it and format it. Let me just show you what's going to happen now. Here's some space, output. Here's line 3, we get what we want. You can either put this in a string and print the string, or you can just directly print it. Using the F makes a lot of difference. The F string makes a lot of difference. In this one here, as you see, I added something new. I added 10.3. I want to see the output in line 4. There will be 10 spaces reserved to the value of pi. Let me run this and look at line 3, line number 4, C4. Pi is equal to, you see how much? 10 spaces. 3 of them are decimal digits. Total is 10. 3 of them are decimal. You can do the same even here. If you see this, 10.5. In the line number 1, if you run it, you get same thing now. Line number 1, 10. You can decide how many decimals, the total width of the value. So you have the old style of Python. You have placeholders using format, and the most recent style using text F string. They all do the same, but the syntax is different. Recently, we use this F string style. Let us see a new one here, the old style again. This is maybe the one you learned in the textbook. So we have here name, Marcus, and his number is 42. We will print here in line, let us say 5, and line 6. I want you to see the difference in the output between line 5 and 6. Number is integer here. It's not float value. So when we output %s is a string here. %s is a string here. %d is for integer. However, if you want to add more format to the integer, for example, if I want to reserve 10 digits or 10 spaces for the value number, you can put 10d. Let us see the output in lines 5 and 6. Okay, line 5, Marcos, and 42. In line 6, we get the same output. However, now we have 10 digits reserved for the value number. The width will be wider. You decide how many places to reserve the value depending on your example. So what you see here is all the styles that can be used in Python. They all do the same, but different styles. What you need to remember always is %d for integers, %f for floats, and %s for string. There are so many other choices, but it's beyond the scope of this session. Let's go and see more examples here. A is an integer equals 5. B is an integer equals 10. Here we'll use the F string. 5 plus 10 is, here you have the placeholder, A plus B, and not 2 times A plus B. Here the placeholder is very, very useful. No need for using this syntax. It would be very complex if you do this output using the old syntax, or even this syntax using format. So here, what I'm going to do here, line 7, the output in line 7, will be very simple here. It will be here 50, and here it will be 2 times 50, which is 100. So no need for any extra thing after this. Yeah, no need here to come and put some format and everything. Everything you want can be done inside. I have shown you this example here using the F string with additional format, or even without any format, you can do it like line number 3. I can remove the format in line 3 and just put the value. Here also, I'm not using any format. I'm just using it as a placeholder. So 5 plus 10 is 15 and not 30. These are different styles of changing or displaying the output. Displaying the output does not change the value. Let us review this quickly. Here we look at this example. Here we look at this example. By placeholder .2f format by. It will give you 2 digits and the number. In the next one here, what you get is you get the same value, but now the width or the number of digits reserved will be 10. 2 of them will be reserved for decimal. Now I'm using another value, which is sales. The sales is big number here, as you see. Sometimes when it comes, especially in businesses, if you want commas in thousands, you can do also format. You just put person, colon, comma. I'll show you the output here. Look at the sales and see the output at the sales. Run. Okay, see the sales? They automatically added commas. Let's see a huge number like this one, distance. Okay, so here distance is a float, is not an integer. Sales was an integer. You can do the same, comma, 0.3f, and you can use format distance. I can run this now and show you the distance. If the number is huge and you want commas, just add this one. Let's see the next one is very simple here. It's a for loop. We're not discussing for loops now. If you print it, if you print X, you're going to get 1 to 10 in this loop. So the last thing you expect in my output here, you're going to get 1 to 10. Or even 0 to 10, not 1 to 10. Let me make it 1 to 10. Okay. So now if you want to get a different output, like if you want zeros, 0 or leading zeros, we call them, here, you can get leading zeros. As you see now in the last output, you will see leading zeros. See? 001, 002, 003, and 010. How many leading zeros you decide here? If you just want 1 leading zero, you do this. If you want 2 leading zeros, you do that. It depends on the length of the values. See now, I'm just getting 1 leading zero because I have values. If you make it 3, you will get leading zeros. So that's all about formatting. We need to know formatting in Python. This is the very basics, mainly related to strings, integers, and floats. Our first question will be converting some Celsius temperature to Fahrenheit, Kelvin, and Rankine. The user is going to input a value in Celsius. We're going to convert it to all the 3 other systems like Fahrenheit, Kelvin, and Rankine. And we will output all the details. The formulas are available to us. What we need to think first, what is the type of the input? Is it integer or float or a string? If it's an temperature, definitely it's going to be a float. You cannot say it's going to be an integer. So let's write this program first. So this is our program. We will start writing from here. We need the Celsius temperature. And Celsius is going to be float. This is how we read float from the user. Float input, and I can say enter Celsius. Now we have the Celsius temperature. Then we are ready to get or calculate the Fahrenheit, Kelvin, and Rankine. Very simple. We can do F is going to be equal Celsius times 1.8 plus 32. No need to do any brackets here because multiplication will be done first, then addition, which is fine. If you want to be on the safe side, you can add them, but in this example, no need to add them because always multiplication is going to be ahead of addition. Let's do Kelvin now. Kelvin is equal to Celsius plus 273.15. Very simple, straightforward. Let's do Rankine equals Celsius plus 32 plus, you can do it this way, or you can do it, there are other ways like 1.8 times Kelvin. You can do 1.8 times Kelvin. What I want to say, you cannot do this step if Kelvin is not calculated yet. Now I can do this because Kelvin was calculated before line 11. But however, if you try to calculate Rankine before Kelvin and using the value K, you get an error because this value at line 10 still not known, undefined. If you put the mouse here, you see what is not K is not defined. If you switch this and do the calculations after that, then you get no error. So now let's do our output. We want our output to be formatted. All of them needs to be like a table, for example, let us say. I can do the output using any one of the formats here. So it depends how you want it. For example, I can use the easiest, I can use F string, I can use the old style, I can use format. It's up to you which one you want. It's up to you which one you want. You can take any of them. Let me use any one, for example, here. I will see if we have one with multiple things. Without format, I will use something like this. Let me show you how the output, I'm expecting it to be. F, Celsius, for example. Celsius. I can there use placeholders. I can say Celsius. I want it to be formatted, for example, 5.3 or 2F. This is Celsius value. I can use equal sign here. And then I can say is equivalent to Fahrenheit, for example, Fahrenheit, and use the value F and same format. This is one way of doing it. All the other ways are possible. So now here, I'll do the same thing, F. Let's just try to test this. If it works, then we can apply the same thing. So now your output will be Celsius equals to the value of Celsius, formatted 5 digits and 2 decimals, equals to Fahrenheit. Let us say here, use colon, okay, for the output only. So let me run the first time here. Okay. Enter Celsius temperature 40.5. Celsius 40.5 is equal to Fahrenheit 1.49. So we get the right output with the right format. Well, since we got that, I can go now ahead and change and add all the remaining things. So now here I will say Franken or Kelvin first. And here I'll use K. I will use Rankine here. And I will use R. So that's it. Let us test our program. Our Celsius temperature is 44.9. So here you get Celsius, this much is equal to Fahrenheit, that much, and all the remaining things. I'll just change one of them. For example, I will do this for one of them so that you don't get confused. I'll do that here. For example, I will do here Celsius. And instead of, I'll use the old style format. Celsius, this much. And here I'm going to say 2F. Okay. And I'm going to say is equal to Rankine. And again, I'm going to use the same format. And here in the percent, I'll say R. And first one is Celsius. So let's see the output of the last line. Are we going to get the same thing? Let me run this. First, clear some space. Let me run this and see what happens. Our Celsius temperature is 44.9. We see that we are getting the same output using different styles. This is the latest Python style, and this is the classic Python style. And this concludes our first example. Go ahead, ya shabab. Any question on the first example, on the output, on the input, on which the types of the variables? I try to address the problem. I know you can solve this, but I try to address it from many different angles. Go ahead, ya shabab. Do you have any question before we start the next one? I wanted you to see different ways of formatting. In the second program, we're going to calculate number of calories from fat and carbohydrates. Fat grams multiplied by 9, we get the calories. Carbs multiplied by 4, we get the calories. So the program is going to ask you how many grams of fat and how many grams of carbs. Then we need to calculate the total calories of each category and the total of all calories gained. So first, what's your input? The input will be fat grams and carb grams. Since this is not guaranteed to be integer, then you must use floats. Once you get the fat grams and the carb grams, then you can calculate calories and total calories. Let's do this quickly. So our input will be fat grams, and the question will be float. Input fat grams. And we'll do the same for carb grams. And here say carb grams. Now we need to calculate fat calories, which is equal to fat grams times, as you see here, 9. 9. Then we need to say we calculate carb calories. Carb calories. We just change the name here to be fat calories. Carb calories. Okay, is equal to carb grams times 4. So now I can also calculate total calories. Total cal, which is equal to fat cal plus carb cal. So now it's output. Output, you can format it in any way you want. I will just do it quickly. Print. Okay, print For example, here, I can use F string. I can use anything, any you want. I can say fat grams, comma, uh, grams of fat and comma, carb grams, comma, grams of carb. Okay, I can make another line now to show the total. Okay, okay, now fat. Okay, now I can say here, I'll change the style now. I'll say fat calories. Okay, and here I say fat cal. And then I can say carb calories, and here say carb cal. Finally, total calories already calculated. Total calories. Okay. Yeah. Hopefully the program runs from first time. Let me clear some space and run this. Fat grams 190, carb grams 56, 190 grams of fat and 56 grams of carb. Fat calories 1,700, carb calories 224. Total calories is this much. And I believe no need for format here. Everything is fine. You sometimes need format when it comes to money, scientific calculations, or specified in the question. The third question will be finding the total sales of tickets. There are 3 seating categories at Camp Nou Stadium: Class A, Class B, and Class C. Class A, $25. Class B, $18. And Class C, $13. So we need to write a program that asks you how many tickets for each class. And we have 3 classes. Then we need to display the total money or total amount for each class and the total sales. Before we start writing code, our input is going to be number of tickets. So this is going to be integer. The cost is 25, 13, but we cannot guarantee the cost is not going to change. Maybe you're going to add some fractions. So my input is going to be integer, 3 integers: number of tickets in Class A, number of tickets in Class B, number of tickets in Class C. Let's go ahead and write the code directly. So I need 3 inputs from the user. Let us say Class A count. Let us give a smaller name. A tickets. Okay, equals integer this time. Input, how many? Class A tickets. And let us say that we tell him also upfront that it's going to be $25 each. So the user is going to input Class A tickets. Once we do this, we can go and do Class B and Class C. So here we can say B tickets and C tickets and change this and change the value. This one is 18 and the last one is 13. Here say C. So now the user is going to input the number of tickets in Class A, B, C. So let's do now. A total is equal to A tickets times what? 25. B total. B total, new value, okay, is equal to B tickets times 18. And C total, C class total, is equal to C tickets times 13. Now we know the total. The total of all the totals will be grand total, let's call it. Grand total is equal to A total plus B total plus C total. Come on, we can now output it. However, we can do a minor change here. We can define some values here. Like class A price equals 25. I can say next class B price and class C price. Class B 15 and class C price is equal to 13. Now, instead of using the values directly in my program, and remember, your program might be very long, I can use the constants I defined here. Later, if you decide to change the price, you don't have to look in your program everywhere and change the values. No, you just need to come here and change the value. For example, 29, خلاص, no need to do anything in the code because you are using this value all over your code. So I'll just make it 25. Now I know the totals and I know this thing. Let us do some print. Print, let us say A tickets, comma, class A tickets, okay, total, class A, and now I can say here A total. Does that make sense? Now I can, okay, also say B tickets, class B ticket, total class B is equal to B total, and C tickets, the output will be number of tickets first, then the text you see here, then total of all classes. B total, we forgot to do one calculation. Total tickets, how many tickets يعني you're gonna buy? Total tickets is equal A tickets plus B tickets. This is number of tickets, okay? Plus C tickets plus C tickets. Now I can say, okay, you bought, and here total tickets, and finally print grand total. I can say here, what did we call it? Grand total. I can add here dollar or something want. Let me save this and see how the program runs. First, the program is going to ask how many tickets in A, 10, and 5B, and 4C, or 3C. 10 class tickets A total 250, 3 class tickets B, and 3 class tickets C, and so on. If you do formatting here, you could make your output much better. You can reserve the same number of digits here. So all the lines or all the columns will be aligned. Yani you can do a lot of formatting, the things we learned from here. But since we explained this in the beginning, no need to redo this again and again. And problem solved here now. Grand total is this much. Next question is, we need to write a program that calculates the volume and surface area of a cone. So two things need to be calculated and displayed. What we need to do in order to calculate the volume and surface area, we need the user to enter radius and height. And it's clear that radius and height are both going to be float. Volume is also float. Surface height, surface area is also float. The formulas needed are available here. If you notice, we're going to use pi. So the best thing is to do is to define it at constant. And here we need to use square root. Square root, you cannot write a simple code to calculate square root. So what we're going to do is to use the math library, built-in library in Python. So let's do the cone code here. Our input is going to be first radius. So I can say here radius is equal to float input enter radius. Second one, we need height. Same thing, we're going to say height if float enter height. Now I have all the input from the user. I'll be switching back and forth between to see the formulas. Let us see the volume. Volume is equal to 1/3 pi r square h. So we forgot to define pi. Let us say this is the value of pi. And now we need 1/3. If you do 1/3 like this, okay, times pi times radius square star star, get power. And I forgot the remaining part. H times height. Whenever your expression gets complicated, best thing to do is R is not defined, which is radius here. I did not use R. If you think using brackets help you, then that's fine. So this is our volume. However, now in the next formula, we need the square root. So let us see how we import math. Very useful library and built-in library. You don't have to do anything to use it in Python. So now the second thing to calculate is surface area, which is by r square root of r square h square. So let me do surface. Call it surface area, which is equal to pi times radius times, back to cheat, r square h square plus. Okay. So now we need to do math.sqrt. You see the square root here. SQRT, let us find the total, which is radius square plus height square. Good expression, and hopefully we get it right. Now, I don't see any problem here. We will calculate this first, then we will do the square root, then multiplication will be left to right. Oh, we are only using multiplication operator here. Let's see this now. Pi r square h square. That's it. So now I can output print. Let me use f string this time. F. I can say a volume. Volume is equal to, I'll use volume here, and I'll use some kind of 10.3 F. in this. And I believe I misspelled volume. Let me do it right. I will do the same thing now for surface area. Surface area is equal to, and I will use surface area. I'll use the same number of digits in both ways. Let me save this and see when I run it what happens. Let me clear first something. Clear, run. So I'll ask radius 3.6, enter height 8.4, volume is equal to this much, surface area is equal to that much. Hollow cylinder is our next example. Write a program that calculates the volume and total area of a hollow cylinder, right circular hollow cylinder. The program should ask the user to enter inner radius, outer radius, and height. So we have 3 inputs from the user. All are float, as you see, inner radius, outer radius, and height. Volume is clear here, and area of the base should be calculated. Then lateral surface area should be calculated. You need to sum both of them to get the total area. So the way you calculate area of the base first, lateral surface area, then you get the total area. Volume is clear. And formulas, we need pi, we need height, and we need radius. We will call them inner radius and outer radius. Inner radius will be R2 here in this example. Outer radius will be R1. So we have 3 inputs from the user. All are inner R. All are float. Input. Inner radius. And copy. Okay. Outer radius, and finally height, which is height. That's it. So we have all the input needed. Once you have all the input, you can start the processing. Once you finish processing, you do the output. Let's do the volume first, since it's one way, one formula. We need to cheat something. Pi h r square minus r2 square. So we need to define pi. Pi is equal to 31.45. So this one is equal to pi times height times, okay, inner, outer, r square minus inner r square. This is our volume. Now we need to calculate the area of the base, which is by R1 minus R2, which is fine. So base area is equal to pi times, same thing, same one here. And I still need to calculate lateral surface area, which is equal to 2 pi h r1 plus r2. 2 times pi times height, and last one was multiplication. Yes, multiplication. Inner radius plus outer radius. That's it. Total area will be, now total area is equal to base area plus lateral surface area. That's it. So now we just need to do the output. I can say print, make it simple, volume, and here do volume, and your output going to be the same. Print total area. Total area is equal to total area. Let us save this in some space. Run inner radius is 6, outer radius 3, height 6. I think I made a mistake. Inner radius should be smaller than the outer radius. Maybe I did a mistake in all of the calculations. Which one is inner, which one is outer? But let us see. Inner radius is 3, outer radius is 9, height is 8. I believe this is correct now here. When you do this, you get the right result. Height is input,